Good day, sir. We will be presenting our solutions for the problem set 2. So let's begin in number 1. So here in number 1, we see a connection of resistors. So these two resistors are connected in series. So what we will do is we will add them. So 1 plus 1 is 2. So after that, the image of the connection will look like this. We can see that these two resistors are in parallel. So by adding the two resistors, we can make a one resistor, and that would result to this image. So in this image, we can see that these two resistors here resulted to 2/3. And after that, we will perform a transformation of delta to y. So from delta to y, we will be using this three resistors here, and the other one is the three resistors below. For that, we will have to transform them. So the three resistors here have the same resistance, which is 1. So according to the solution, Ry is equal to the R of the delta divided by 3. So 1 over 3, which is 1/3 ohms. So that would be equal to the Ra, Rb, and Rc. For the other transformation of delta to y, the values are 1, 1, and 2/3. So for the RD, which is this resistor, it will have a value of 3/8 since 1 times 1 is 1 divided by 1 plus 1 plus 2/3. As for the RE, the adjacent resistors of the RE, which is this, so 1 and 2/3. So 1 times 2/3 is 2/3, and divided by the sum of the three resistors. So that would be 1/4. And same with the RF, since the adjacent resistors of the RF is 1 and 2/3. So we will get the value of 3/8, 1/4, and 1/4. Next is we can see that these three resistors are connected in series, and the other resistors are connected in series as well. So we will add these resistors and these resistors to form a parallel. So in R1, which is this resistor, we will have to add RB and RD, which is 1/3 and 3/8. So 1/3 plus 3/8 is equal to 17 over 24. So the value of the resistor here is 17 over 24 ohms. And as for the R2, that would be RC plus RG and RF, where RC is 1/3, RG is 1, and RF is 1/4. So 1/3 plus 1 plus 1/4 is equal to 9 over 12. The next would be combining these two resistors in order to form a one resistor. So by combining them, since they are in parallel, we will get the reciprocal of the resistor, and then we will raise the sum to -1. So since this is 17 over 24, in this solution it would be 24 over 7. And as for the second resistor, it would be 12 over 19. So 24 over 17 plus 12 over 19 is raised to -1 is 323 over 660 ohms. So as for the equivalent resistance, we will be adding all the resistors. So 1 plus 1/3 plus 323 over 660 plus 1/4 and 1. That would result to 169 over 55, or approximately 3.07 ohms.
In number 2, we are given a circuit, what we can call a complex circuit, and in these three resistors, we can see that we can also redraw this as like this one, which forms like a triangle. And out of this triangle-like resistors, we can then transform it into a much simpler one, which is the Y transformation. So we then proceed to the delta to Y transformations using the equations that are given. So I will label this as node A, node B, and node C. And, and the resistors inside the delta, the resistors in the Y transformation are A, RB, and RC. So in order to get RA, the numerator is the product of the adjacent resistors in RA, which is 30, 30, and 20. 30 times 20 over the sum of the resistors around it. So 30 plus 20 plus 12, which then results to 300 over 31 ohms. In RB, same formula. Resistors adjacent to RB over the resistors all around it. So 30 times 12 over 30 plus 20 plus 12 is equal to 180 over 31 ohms. And RC, 20 times 12 over 30 plus 20 plus 12 is equal to 120 over 31 ohms. So next step, as we transform the delta to as we what do you call this one, as we perform the delta to Y transformation, we can then withdraw this circuit into a simpler one, which is this. As we can see, this is node A, RA, which is this one, RB, RC, and the 60 resistor that is connected at RC, which is in series with RC, this one, the 60 ohm, and this line which represents the this resistor connected to the 10 ohm resistor. So this is a much simpler one. And as we can see, these two resistors, the RC and the 60 ohms, are connected in series. So we find the equivalent resistance, or the equivalent resistance across these two resistors. So 120 over 31 plus 60 is equal to 1980 over 31 ohms. So this is the resistor across these two combined resistance of these two resistors. Then we withdraw the circuit again, which forms like this, from this to this. And in this circuit, we can observe that these two resistors are connected in parallel. So in order to get its total resistance, we use the formula in finding the resistance with two resistors, which is R1 times R2 over R1 plus R2. So 180 over 31 times 1980 over 31 all over 180 over 31 plus 1980 over 31, which is equal to 165 over 31 ohms. Then, after combining the two resistors in parallel, we now have this circuit. And in this circuit, we can observe that these two resistors are now in series again. So, to find the total resistance, just add the both of them. 300 over 31 plus 165 over 31 is equal to 15 ohms. Next, in this diagram, we can see that these two resistors are connected in series. So to find the equivalent resistance, just add them both. 15 plus 10 is equal to 25 ohms. And now, as we connect these two resistors, we now have a single resistor, which is 25 ohms. And at this point, we can see that these two resistors are now connected in parallel. So finding its total resistance, we just multiply R1 and R2 over R1 plus R2. So 25 times 25 over 25 plus 25 will result to 25 over 2 ohms. And lastly, this diagram, which is the final stage of the circuit, the simplified form of the circuit, we can see that this is a series type. So we just add all these values to get the equivalent resistance. So 5 plus 25 over 2 plus 15 will result to a total resistance or equivalent resistance of 32.5 ohms. We are given the circuit alone, this one. And by, as what we have uh, searched or observed at YouTube, we use the nodal analysis or what the node voltage something something. So as using that method, we now apply the directions of the current at each node. So at first step is we label each nodes. So as you can see, A, node B, node C, node D, node E, and node F. So excuse me. So at in each circuit, we must apply a reference node. So this node is where is a node where which it connects all branches. So by convention, we apply this reference node at the bottom, and also um, what we call this one in the middle. But just hunch lang, sir. So at this node, V is equal to 0. So and we can also observe na in this circuit is a short circuit, which means that voltage that will flow through each node is equal to each other. So now, since we have already identified nodes and the direction of the current, we now start for this solving of IL, this one. So the given I4 is equal to 3ix. If I may add, since we are calculating required to find IL, we assume that the direction of the current is going towards IL, except this one, the direction of I2. Since if we tried to put it directing to the right, we have obtained a negative value, so I switched its direction. So back to the given, I4 is just equal to 3ix. And as we can see here at node E, ix is just equal to I8, which gives us I4 equal to 3I8. And I1 is given, which is 6 milliamperes, which is equal to 0.06 amperes, and I6 is equal to 3 milliamperes, which is also equal to 0.003 amperes. So now we are asked to find I9 or IL. So by Ohm's law, the current is just equal to the voltage over its resistance, or potential difference over the resistance. So by identifying the given, we now apply the Kirchhoff's current law or the junction rule. So at node B, KCL, the left side of the KCL, this side is the currents entering a certain node, and at the right side is the currents leaving the node. So at node B, I1 is entering node B, so which we position it at the left side. So I1 is equal to I2 plus I3, and these currents are the ones that are leaving node B. So since we are given, we have these given values, we just substitute it to the equation at hand. So 0.006 is equal to the potential difference over R, or I2 plus I3. And the potential difference, VA minus VB, is just equal to also a voltage lang man. So we denote it as V. So the final equation is 0.006 is equal to V over 6,000 plus I3. Then we proceed to node C. So at node C, we can notice that the current entering node C is just I3, and the ones that are leaving are I4 and I5. So which gives us I3 is equal to I4 plus I5. And we know from this equation na I4 is just equal to 3I8. So we substitute it here and gives us I3 is equal to 3I8 plus I5. So now at node B, just the same, we apply the KCL. I5 is just equal to I6 plus I7. And we know that I6 is equal to 3 milliamps, or 0.003 amperes. So now we substitute it. I5 is equal to 0.003 plus I7. So proceed to the next node. At node E, I7 is equal to I8 plus I9. So I8, if you analyze I8 is just by Ohm's law, we can get I8 by voltage over its resistance. So we denote it as this one. Ix is equal to the voltage at E over its given resistance, which is 2 kilo ohms or 2000 ohms. So now we have this unknown equation. Ix is equal to VE over 2000. So we just substitute I8, this value, into this equation. So we now have I7 is equal to VE over 2000 plus V9 over 3000. And overall, I7 is equal to V over 1200. If I may add, we get V9 also by Ohm's law, since uh, V9, to get I9, we just use Ohm's law, which is V9 over its resistance that is given, so 3000 ohms, which is why we come up to this value in this equation. So now, since we have identified new sets of equations, we just substitute these equations to find the other unknowns. So at node D, uh, in order to solve for I5, we substitute the I7 equation. So I5 is equal to 0.003 plus I7. So as we know, I7 is V is over 1200. So 0.003 plus V over 1200 is equal to, is now I5 is equal to 3.6 plus V over 1200. So now this adds the now nabag-o na equation. So we use this to find the other unknown. So at node C, we can see nga I3 is equal to 3I8 plus I5. So now we know nga nanatay I8 and I5. We just substitute these values in order to get I3. So 3I8, which is VE over 2000 plus 3.6 plus V over 1200. So which gives us 3V over 2000 plus 3.6 plus V over 1200 is equal to 5600V plus 7200 over 2.4 times 10 raised to 6. So finally, the last unknown, we substitute again those given values to find another unknown. So at node B, we know at node B, 0.06 is equal to V over 6,000 plus I3. So now since we have obtained I3, we just substitute its value. So 0.006 is equal to V over 6,000 plus I3, which gives us V over 6,000 plus 5,600 V plus 7,200 all over 2.4 times 10 raised to 6. So we calculate the voltage. So voltage is equal to 1.2 volts. And since the circuit rather is a short circuit, we may assume we may conclude that voltages at all nodes are equal. So which gives us voltages at A, B, C, D, E, and F are V is equal to 1.2 volts. So now, in order to get I8, IX or is equal to I8 and IL is equal to I9, we substitute the value of V, which is 1.2. So at IX is equal to V over 2000, and when we know na V is 1.2, we just substitute it. So 1.2 over 2000 gives us 6 times 10 raised to negative 4 amperes. On the other hand, IL, or the current load, is just by Ohm's law is equal to V9 or V over the resistance, which is 1.2 volts over 3000 ohms is just equal to 4 times 10 raised to negative 4 amperes.
Number 4, we are given this circuit. The circuit has two source voltages, so we can just add them. For this source voltage, it is a voltage rise, so it would have a negative sign. As for this voltage, it is a voltage drop, so it would have a positive sign. So as for the total source voltage, it would be negative 20 plus 60, then it would be equal to 40 volts. As for the resistors, since this is in series, we can just add them all. So 4,000 ohms plus 10,000 ohms plus 10,000 ohms and plus 6,000 ohms would be equal to 30,000 ohms or 30 kilo ohms. So we have here a dependent source. So this is a current dependent voltage source. So from here, we can redraw a simpler circuit. So this is the simpler circuit. So we have a 40 volts, a 30 kilo ohms, and the dependent source. So in getting the value of Vx, we can use the KVL. So as for the KVL, since this is a voltage drop, it would have a positive value. And we assume that this is a plus minus sign, so it would be positive, as well as this one. So 40 plus Vx plus 2000 Ix is equal to 0. So we can see that Vx is equal to negative 2000 Ix minus 40. And we know that Ix is equal to Vx over 30,000. Since V since Vx is equal to negative 2000 Ix minus 40, we can just substitute it here. So this would be the form over 30,000. So we can multiply 30,000 both sides and we will get 30,000 Ix minus 2,000 Ix minus 40. Uh, so we can add 2,000 Ix both sides. So the Ix here will be cancelled. Then as for the left side, it would be 32,000 Ix. So in getting Ix, we divide both sides by 32,000 and we can get Ix to negative 1.25 milliamps. Since we have the Ix and we were asked to the power of this dependent source, we know that the power is I times V. We have I and we have this V. So multiplying both, we get negative 1.25 milliamps times 2000 Ix, where Ix is equal to negative 1.25 milliamps. So for the power, we get 3.125 milliwatts. So number five, we are given this circuit uh, where we are asked to solve for V1. So V1 is equal to 2I times 4K. So V1 is equal to 8KI, and VR, where R is this resistor, we can get I times 2K. So by using KVL, um, since this is a voltage rise, we will have a negative 72. And we assume that this is a plus here and a minus here, so that would be plus 2KI. And then plus, this is a voltage dependent voltage source which has the value of zero point 0.5 V1. So this is 0.5 V1, and that would all equate to 0. Negative 72 plus 2KI plus zero point 0.5 V1, which is 8KI, is equal to 0. So 72 plus 2K plus 4K, so that would be equal to 6K. So negative 72 plus 6KI is equal to 0. So we can get the value of I by transferring 72 to the other side, which would result to a positive 72, and then dividing it by 6,000. So that would result to 12 milliamperes. As for the V1, we can solve V1 using this equation. Since V1 is equal to 2 times I, where I is 12 milliamps. So 2 times 12 milliamps times 4K. So that would be equal to 96 volts.